Alright, hello there folks. This is our second note on our review of right-angled trig. It's part 2. There's 2 pages. So I'll go through this, kind of following along with what we've been doing in class for the first little bit. We're going to do a question here where I need you to find h, or the hypotenuse, in this triangle. So for this 50 degree angle, we see that the 5 is opposite the 50, so O equals 5. And then we use sine, cos, and tan, and the calculator, sine of 50, cos of 50, and tan of 50. But you can also use the trig tables if you wanted to get these decimals. Just a reminder, is sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And an easy way to remember that is so, ka, toa. Right? So since we know the opposite, which is 5, and we're looking for the hypotenuse, we're going to use this ratio here, which is the sine ratio, because it brings together the opposite and the hypotenuse. And we know that the sine of 50, as indicated here, is 0.7660. So that means 0.7660 is the opposite over the hypotenuse. Putting in 5 for the opposite, we still have the h. And now we get to a situation like we've not been in before, where the unknown, in this case the hypotenuse, h, is in the bottom. So if you look back at all the other examples that we did, when we solved one of these problems, these equations, it was either going to be that the side length that was known was divided by the 0.7660 in this case, or the other way. So it was always a division question. But if you try this right now, you'll get 5 over 0.7660, which is 6.527, and if you divide them the other way, you'll get 0.1532. Now, you might be saying, well, Chris, I could also multiply the two numbers, okay? If you do, you're going to get a number that's less than 5, because you're taking 76.6% of 5, which is less than 5. But if you look at the picture up at the top, the hypotenuse has to be more than 5, or h has to be more than 5, because you already have a side length that's 5, and you know the hypotenuse has to be the greatest side. So if you look at this value here, there's no way that 0.1532 can be the answer, and there's no way that whatever this evaluates to, which is probably about 0.38 roughly, 3.8, sorry, 3.8. There's no way it can be 3.8, because the hypotenuse has to be more than 5. So you know that this is the answer, right? So I just make a point here saying this is a scaling exercise using one of 3 values, sine, cos, or tan, results in multiplying or dividing a side length by the value. And usually common sense can tell you which method is correct. So if you're not someone that's strong with, doing solving equations, then you can try, like, I'll multiply the 2 values, and then I'll divide the 2 values in one way. So again, I multiplied 5 and 0.7660 here, and then I divided them in one order to get this 6.527, and I divided them in the other order to get that. And more often than not, there'll only be one possible answer that is correct. And you can see here, because it's got to be more than 5, you know that the correct answer is 6.527, right? There are other ways to deal with solving this equation when the unknown is in the bottom. I don't really want to get into it because it kind of isn't in line with the way we've been doing things so far. So let's go on to the next question. The next question deals with using trig to find angle, and it's pretty straightforward. So let's say we were trying to find this angle here, f. And well, we know that this is the opposite side because it's opposite the angle that we're looking for. And we know that this is the hypotenuse, which means this here has to be the adjacent. So if we're going to use the 2 sides that we know, opposite and adjacent, it makes sense to use the tan function, because we know O and A, which is 5 divided by 5. When you divide them, it gets you 1. Right? So the tan of an angle is equal to 1. So since tan f equals 1, then you can do the angle is the inverse tan of 1, which is 45 degrees. So if you're using the trig tables, it's like going into the tan column, find when the decimal is equal to 1, and then moving over to the left column and realizing that it corresponds to 45 degrees. Now, on your calculator, there should be a way to do inverse tan to get 45. Sometimes you have to make use of the INV button, so you'd have to hit INV plus tan, and that's before or after you put in the 45 degrees, depending on the way that your calculator works, or probably the more common one is to hit the second function key, and then tan, and it'll do the second function of that key, which is tan to the negative 1. Alright, so just be aware of that. Alright, so the next question is a bit of an application. The general rule of thumb for setting up a ladder is to place its base a quarter of the working length of the ladder. So, for example, if you have a ladder that was 10 feet, then if you divide it by 4, that means that the 2.5 feet, it means the bottom of the ladder should be no more than 2.5 feet away from the wall that, let's say, that the ladder is leaning up against. Now you can imagine that you don't want this ladder to be too steep, because then you can easily fall over, so you wouldn't want it like this. And at the same time, you don't want the ladder to be like this, because then the top of the ladder is likely to just slide down. So there's something to say about, or they're saying, and I got this off a website, that whatever the length of the ladder is, or the distance from the ground to where the ladder hits the wall, about a quarter of that distance should be the distance, this distance here, which is how far the base of the ladder is away from whatever you're leaning the ladder up against. Right, so pick a ladder length. I said 10 feet, just as an example. Distance from wall is a quarter of that, which is 2.5 feet. So I drew this little diagram for us here to model the situation. 10-foot ladder, 2.5 along the bottom, and now I want to know what's this angle in here. What's that angle in here? Okay, so going along, if that's the angle, we know that that's the opposite, OPP, and we know that this is the hypotenuse, and this is the adjacent. So given that we're working with, we know the adjacent and we know the hypotenuse, it makes sense. Over here, adjacent is 2.5, the hypotenuse is 10. It makes sense to use the cosine ratio. Remember, so ca toa. So we know A and H, so we use cosine. So the cosine of angle A is A over H, which is 2.5 over 10, which is 0.25. And then to get the angle itself, I do the inverse cos of 0.25, and I get about 75, 76 degrees, which is telling you that for safety reasons, you should be leaning up that ladder against the wall at around 75 degrees to be safe. Alright? Alright, next question that we're going to do here, and the final question for this video, is application number 2. A person 1.8 meters tall, so a person 1.8 meters tall stands 36 meters from the base of a tree and measures the angle of elevation to the top of the tree to be 68 degrees. How tall is the tree? So here's my diagram. Excuse my poor drawing for a tree. So there's my tree, and there's my little person who is 1.8 meters tall, and from their eyesight they are able to look up and, using some type of device, measure that the angle here relative to this line here is 68. So you can see here that we have a nice little right triangle. Right, now I do want you to realize that this piece here, okay, that's not the height of the tree, because we're going to have to add on 1.8 at the bottom, which is the height of my person. And that's because the measurement isn't being done from the ground level, it's being done from the height of the individual. So if I just jump over here and kind of take out this triangle, so we see that's the yellow side there, we got an angle here of 68 degrees, and we got the distance from where the person is standing to the base of the tree to be 36. And we want to know this, right, that yellow vertical part. Because if we know that, and then we can add on the little green piece over here, then we'll be in good shape. So this here tells us that this is the opposite, and this is the hypotenuse, and this is the adjacent. So given that we're looking for the opposite, and we know the adjacent, we're going to deal with O over A, which is tan. And remember, so, ta, toa. So we need the opposite, and we know the adjacent. So that's why we use tan. All right? We don't need the hypotenuse, so there's no reason to use the sine ratio or the cosine ratio. So the tan of 68, so let's go back here. The tan of 68 is over A, which is I'm right there. So I do the tan of 68 on the calculator, and I get 2.4750. Opposite is x, and 35. And this tells me that something out of 36 is 2.4750. So I need x to be 2.4750 times 36. The other way to look at it is x is about 247.5% of 36, right? So again, if you get messed up here and you're like, do I multiply the two numbers together, or do I potentially divide them? You can always try some other alternatives, but you know, this is in line with what we did before when we were trying to find out percentages of decimals and stuff like that. Anyway, we multiply those together and we get 89.1. And last but not least is the most important thing here is the conclusion, or to make sure, maybe not the most important, but to answer the question, the height of the tree is not 89.1, because that will just give you this piece here, which is this piece over here. Okay, you got to add in the 1.8, which is this little piece here. And if you do that, you get 90.9 meters, which is the height of the tree. Now, I do want to bring one thing to your attention, and that is, I did talk about something here called the angle of elevation, and you're going to see that in a few more questions. The angle of elevation and the angle of depression are angles either looking up or down. The important thing, and the mistake that a lot of people make, is the angle of elevation is always, and the angle of depression are always relative to the horizontal. So notice that this here is the angle of elevation because it's the angle up, and this is the angle of depression, the angle down. What people sometimes do is they quote this here as the angle of elevation, all right? And they quote this here as the angle of depression. Remember, that would be an angle relative to the vertical, and this here would be the angle relative to the vertical, which is not correct, right? You always want to do the angle relative to the horizontal. So that's this angle for the depression angle, and relative to the horizontal, that's that angle for the elevation. Okay, so it's all very, very, very important. This is always relative to the horizontal line, right? Not vertical. All right, I think that's just about it. So hopefully this video turned out well for you, and we'll talk to you later. Bye-bye.